Hello everyone, this is a chapter about coding summary queries. We will use select statements with having clause and where clause. For having clause, of course, we will need to use group by. We will use rollup and cube operators, and we will see an example with grouping sets operator and over clause. So first of all, aggregate functions. To summarize data, we're using aggregate functions such as average. It can be all or distinct, and expression is usually one column that we are averaging over. Sum, which is a total of values in some column, min, max, count, and count all. So far it looks boring, but together with aggregate and aggregations and group-wise and having, we are going to see some interesting results. Actually, these functions are used very often when aggregating data for data science pipelines. And together, this is probably the most basic and widely used ones. All right, so first of all, we are going to count all as number of invoices from invoices, and also we are going to count the sum of invoice total minus payment total minus credit total as total due, where this difference is greater than 0, and of course you are very familiar with that difference. This is balance due, as it was called in previous chapters. The result set is one line because we have summed up all the all the balance due and filtered only those where this balance due is positive. Okay. Now we can also use a constant column with an aggregate. So we are doing choosing count again, number of invoices, average, and sum of invoice total from invoices where invoice date is bigger than certain date. So again, the result is one row, and we have a new constant column selection date that we created over here. The use of aggregates really restricts the number of columns, the kind of columns we can use, but we'll talk about it later. We can do a min and max with numbers. So we have some constant column, new column select date that we created in the first line, then counting the number of invoices, choosing max total for highest invoice and min total, and also restricting the dates, and we are getting 114 invoices. This is the highest, this is the lowest, and the first one is a constant column. Okay, we can use min and max with non-numeric columns. Basically, min and max works as alphabetic order in them. And you can see the last vendor is the last one in the alphabetic order, the first one is the first one. All right. Now we can see, we can count distinct vendor IDs, because in our table invoices, it's very likely that vendor IDs are repeated for different invoices. So the number of vendors, count distinct vendor IDs, 34. Number of invoices, that is just count all the lines in the table, basically, even though we say here count vendor IDs, we're counting all the lines because vendor ID cannot be null in that table. And we are also summarizing average and sum. So this is all pretty great, and but kind of not enough information. What if we wanted to group vendors, for example, by state or by city, or by in some other way, and then see the average, for example, for California, the average for Louisiana, and compare them, and that would give probably some insights for data analytics, provided we would have enough data for that. Okay, so we are going to look at group by and having. They come together, so if you grouped by, then you can use a having clause. And of course, after that, you can always order in the way you like to order. Let's go from top to bottom. Select list. That is a list of columns of original table. From table source, there could be some joins in here. There is a filtration where takes place before group by. That is an important distinction with having. Now the group by, and we have a list of columns over which we group by, and having is filtering after the group by. So we are filtering group by results using this having clause. So what can be included in select clause when grouping is used? Aggregate functions, well, like sum or average. The columns used for grouping, those actually go in the select list together with these aggregate functions, and expressions that result in constant values. That is something like what we've seen in the previous examples. Let's consider this example and let us take a little bit of time working on it. So we are going to play with this query, understand it, and then change around a bit. So select vendor ID, average invoice total as average invoice amount from invoices grouped by vendor ID, having average invoice total bigger than 2000, and then order in the descending order by the invoice amount, which is the result of previous grouping. So we group by vendor ID, meaning that we take average for each value of vendor ID, and also after we're done, we filter it by having those averages bigger than 2000. So in this column, all the averages are bigger than 2000, but we first calculate them using group by per vendor ID, what is the average, and then we are filtering them. So just for fun, let me start a new query and copy this and change, and we will compare the results. Instead of having this average, we are going to group by before, do where clause before. In this case, we cannot have an average in here because the where clause filters the original table for values satisfying this condition, and we will get very different results now, or at least hopefully we will see the difference. Now let us compare side by side with the previous query. We have average invoice amount going up by quite a bit, for example for vendor ID 72. So what is the big difference between the two? In the second case, the one that I changed, where invoice total bigger than 2000, we first threw away all the rows with invoice total smaller. So as a result, we have fewer rows for aggregation and for group by and computing the average. And all the inputs for this average are at least 2000. As a result, not all, but some of these numbers will go up, and we will average among fewer of them. So this was to emphasize the difference between where and having. Let's go back to the slides. This is another example, a summary query that counts the number of invoices by vendor. So just count them. We could do that actually in the previous query and add it to the existing query. There is no filtering here, just group by. So vendor ID 34 has 2 invoices, vendor ID 37 has 3 invoices, and 48 has 1 invoice. Let's consider the next example. Notice that the structure here, there is vendor state, vendor city, count invoices, and average invoice total. From invoices, join vendors. So you can aggregate data and group by data from 2 different tables or more different tables, as long as you are doing the join and then identifying on the key, which is in this case vendor ID. So notice group by vendor state and vendor ID. Other than calculated columns over here for aggregation, count, and average, the columns selected are exactly the same that we use to do a group by. That is not a coincidence. You have to do that unless you have some constant valued columns. Otherwise, the group by will not understand how to do that. If you have some extra columns selected but you don't group by that, and you are trying to group by for selected columns only, maybe this combination of vendor state and vendor city will correspond to a bunch of different values in other columns, and group by will not know what to do with that. In any case, this is a nice little example for averaging, and instead of vendor ID, we have vendor state and vendor city. And we are grouping by them, so there may be multiple vendors in Phoenix, Arizona, for example. But we have, in Fresno, in California, but we have grouped them by in one. So the total invoices coming from Fresno, California is 19, and the average among all of those 19 is $1,208 with change. Okay, so we add a having clause right now, so everything is the same. We are adding the condition that the count is of invoices, really we are counting the invoices, is at least 2. So we threw away all the invoice counts 1. Again, having works after the group by, so we did a join between 2 tables, then we grouped by vendor state and vendor ID, vendor city. So we have unique combinations of state and city here, and we have filtered the results to keep only the ones with count 2 or more. And another example with having clause. So having average total above 500, that is after we grouped by and computed the average invoice total, we're keeping only the ones that are above or equal to 500. This will give different results compared to if we were to do invoice total above 500, and they are going to make a point about that. I'm going to show it to you in the student. All right, let us understand this query. First, this is the one with having from the previous slide. We are selecting vendor name, count, all invoices, and average invoice total as invoice average from vendors join invoices on vendor IDs, and we are going to group by vendor name. And now, after we group by, so the average and the count is calculated, we're only keeping the ones with average above 500. So we can examine this carefully, and I want to stress the difference between using having and using where. This other query is very similar. Instead of having, I have a where. Again, where works before the group by. It works filtering the original table for values. So in the original table, we only keep the rows where invoice total is above 500. And we can compare the results side by side and see if there are any differences. So first of all, when we have having, in some cases we have more invoices. That is because some invoices were filtered out before count or average in the case of using where invoice total bigger than 500. Also, we should be able to observe that using where we get very different values of average because if they go up. Before the average was computed, only the values above 500 were selected. So you can compare let us compare Zilka and Zilka. In this case, the average went up and the number of invoices went down because this where clause threw out some invoice that whose value was less than 500. So do not confuse where and having. All right, we can have a summary query with a compound condition in a having clause. Select invoice date, count star as count O as invoice quantity, sum invoice total as invoice sum from invoices grouped by invoice date. So in this case, we are grouping by invoice date. We are looking for number of invoices, for example. This count will count the invoices on each single day when there were invoices. So on some days, maybe there were no invoices and we're not having zeros because those dates were not in the table to begin with. Now, having invoice date between these two, I guess this is January, the month of January, count bigger than 1, and sum invoice total bigger than 100. So after the group by, we are filtering the results of group by choosing conditions for January and only count above 1 and sum of total invoice total above 100. So we have a same query with a where clause. We basically pushed the condition about the dates to the where clause. And that is actually does not changing anything because the dates in the results and after group by and before group by were the same. All right, so the results are the same. There is often more than one way to write a query to get the same results, but in general, do not confuse where with having. All right, now it's interesting that we can include in the same table the final summary of some form, and that is the next goal for us to understand how we can do that and various ways to do that. So here we're selecting vendor ID and doing everything as we did in previous examples with rollup. So the very last line over here, it sums up all the invoices that were in the table. There was 114. It doesn't give any value for vendor ID because it collected together all vendor IDs, and this is the total for the invoices. There is another way to do that, but I'm sticking with the one that is standard probably for all the SQL. All right, so summary query with summary row for each grouping level. We can have more than one column in the group by, and we want to do a roll up for more than one column. So let us understand this. Vendor state, vendor city, count O as quantity of vendors from vendors. So we are counting vendors for every state and city combination. So where vendor state is in these two states. So it takes only two values, New Jersey and I don't know what the other one means. Group by vendor state, vendor city with rollup, and order by the same two variables. So with rollup means the following. Look at first we have New Jersey, Washington, New Jersey, Fairfield, so state and city combinations. And then we have New Jersey and no city value. We are summing up all the values in the city. So this is the roll-up over vendor city. Now for the other state, we also go through all the available cities and towns in the table, and then we do a roll-up for the other state with a total of 2. And finally, we do the roll-up on both variables. We do a roll-up on vendor state and on vendor city, and we get the grand total for the whole query with this where restriction. So hopefully it makes sense. It does give more information in one table. For example, we could do this particular roll-up line as a separate query, like exactly the way we did it in the very beginning of the chapter, where we had one line results. And we could do it for this one, and rollup provides a way to show all the information by state and city in this case, then just by state, and then overall for these 2 states in this particular case. So we can, of course, do a rollup. The rollup is not the only thing that we can do. We can also do with cube. So rollup was rolling up in order. So let us look back and notice that order. So first of all, vendor state, and then, first of all, vendor city, then vendor state. You kind of read it from right to left. So the rollup was happening by cities first over here, and lastly by vendor state. In this case, vendor state, we don't get the other order. For example, a rollup for a given city, Washington, and every state. That's how the rollup works. But with cube, we do get that. So let us consider this example, vendor ID. We are summing up invoice total, and we group by vendor IDs with cube. In this case, it actually gives the same results as a rollup would, but so basically it aggregates all the invoices across all the vendor ID in the last row. Okay, now back to that previous example, but with cube instead of rollup. First of all, notice visually there is more rows, so we'll have to get to the bottom of it. And the first rows are the same. We aggregated by New Jersey, by state and city, and then we aggregated by all the cities in state of New Jersey. So that is what the rollup would do. Up to here, the rollup will also show the very last line, exactly the same, but we are dealing with cube, so it allows to roll up by the values of cities. So we're rolling up across all vendor states and fixing the city now. So the state can be anything, and city is Washington. There are 2 cases like that, and we can see them from the table. So cube basically allows you to roll up in every order, whereas the rollup itself is respecting the order of your columns. What it has to do with the cube, why it is called the cube, is a little bit of a mathy thing. It comes from describing cubes in mathematics. And if any of you are curious, I could talk about it another time. Now we can also use grouping sets, and grouping sets is really telling us how to group. So we want vendor state and vendor city. So our state and city, it's either we are grouping by state and all cities, like the first 2 rows, or we are grouping by city and all states. I mean, in this case, there are just 2 states. So that is another option for using grouping sets, is another option to do the group by and include the roll-up columns in any order. Let us look at this more sophisticated example. So vendor state, vendor city, and zip code. And we are counting the vendors, grouping by grouping sets. And okay, so vendor state in these two states. We are doing grouping sets. So the first two are together, and vendor's zip code is by itself, and also there is an empty group. So let us understand what it does. So vendor state and vendor city are together. So here they are. All the vendor state and vendor city combinations are in here, and we can roll up by all vendor zip codes. And now we are rolling up by these two and various zip codes. I'm not sure how much sense this part makes for this particular problem, but basically we fix a zip code and we aggregate all the values in the other two columns. And I guess there could be two different, theoretically there could be two different vendors in one zip code, but in this case we don't have that. And finally, we have this empty pair of parentheses, and that corresponds to the last column, so roll up by everything.